Hey everybody, we're down to the last week. We've made it through this distance learning, second to last video of the year. Very, very exciting. This should be a very short one because what we're going to do today is going to be condensing logarithms. And last week on Thursday or Friday, you watched a video where you expanded logarithms. You used the properties that are on your screen right now to expand logarithms. Well, now we're going to use these exact same properties, the product property, but instead of expanding them and going from this side over to this side, we're going to go the other way. You're going to start with things that are split up, and you're going to combine them into a single log. So all of your answers today are going to have only one log in the answer. And this is actually easier for most people because in math, it's natural to simplify. You want to make things smaller. That's what we've done forever in algebra. We've taken expressions and we simplify them. So we're going to take a bunch of logs and condense them down into one single log. So the properties are just here in case you didn't write them down from your last lesson or something like that. But if you've already got those written down, don't waste your time writing those down. We already have those. So those are our three properties of logarithms we're going to use today. There is one piece of terminology that you're going to see today, and that's called a natural log. And the natural log is what we call log base E. Now we said yesterday or 2 days ago, whenever you watch the video, we said that the base of a log, if there's nothing written there, is 10. Well, this is another special type of log, and E is a special number. E is what's called the natural base because it's named for these logarithms. It's the natural base of a logarithm. And that has a lot of applications in financial math, things like that, that we aren't going to quite get to in this unit that we normally do. But I want you to at least be familiar with the terminology natural log. It follows all the exact same rules of regular logs. It's just instead of being written as a log, it's abbreviated ln for log natural, the natural log. And so the abbreviation ln, and you'll see an ln button on your calculator as well. That stands for the natural log. That's just log base E. And E is just this number, which you can think of it a lot like pi. And it's an irrational number. It goes on forever. It's 2.718281828. It goes on forever. And it's just this number E. You'll get to use it next year if you take pre-calc and trig. But for right now, we just need to know when we see ln, that's just a specific type of log, but all the same log rules apply for our properties. All right, we're going to just do 3 quick examples and be done for the day. All right, so we're being asked to condense these logarithms, to write them down as small as possible. So we're going to apply the properties to take these 2 separate logs. Now you notice these 2 separate logs have the same base. You can only do this if they're both log base 2 or log base 5, whatever. The bases on the logs need to match in order to be able to write this down as a condensed logarithm. So when we condense logarithms, all we're going to do is follow our rules to make this simpler. Our answer is going to be just one logarithm. So to get there, we are going to first use our power rule. These multipliers in front. We said exponents move to the front. Well, now we're going the other way, and we're saying that we're going to move the exponents up to the top. So I'm going to make it log base 2 of x to the third. That's a 3. Minus log base 2 y to the 5th, because exponents go in front. Or if we're using that rule backwards, exponents move up, the numbers in front move up into the exponent. So we've done step 1. Now step 2 is going to be to write this as a single log. I have 2 logs being subtracted. Well, a subtraction comes from a division. And so our rules say if you are dividing 2 logs, let's try that again. If you have a log and you have a division inside of the log, you can split it into 2 logs using subtraction. Well, we're going backwards today. We're taking the subtraction and condensing it into one log and then it becomes division. So we're using the same rules we used on the homework from 2 days ago, but we're going to be using them backwards. All right, now the next one, I'm going to go ahead and we'll cross that off because we didn't end up using that. But you notice in our answer, we end up with a single log. Sorry, I'm a little bit disjointed today. We'll get better here for the last 2 minutes. All right, our second example, we're going to go ahead and look at this and do a two-step condensing. Our answer is going to be log base 7. All right, and now you notice we have a plus and a minus, and we have numbers in front. So this 4 is going to come up here to the top and make x to the 4th. Then this 3 is going to come up to the top and make y to the 3rd. And those two were added together, so they become multiplication when you write them as a single log. Finally, we have a minus log base 7 of z. So that means divided by z. So our answer here is going to be log base 7, x to the 4th, y to the 3rd over z. Because the plus multiplies the x to the 4th, the y to the 3rd, the minus says divide by c, and the power rule says move the exponents up to the top. So we're using the exact same rules going the other direction. All right, let's look at one last example. It's going to have a natural log in it, and it's going to have something that confuses some people. This divided by 4 causes people problems, but really dividing by 4 is the same as multiplying by 1/4. So we're really looking at 1/4 times the natural log of x. Let me make that go away here, just 1 second. And so it's 1/4 times the natural log of x plus 3 times the natural log of y. So we said the natural log doesn't really matter. It follows the same rules as regular logs. So that means this 1/4 is going to become an exponent. And the 3 is going to become an exponent because the number in front becomes the exponent inside the log. Now I'm adding these two together so I can condense them down to a single log using multiplication. Now the 1/4 power on x is something that we learned in our last section as well. A fractional exponent is really a root. So this is really the 4th root of x times y to the 3rd. All right, so if you were solid with what we did in our last section, this one's going to be pretty basic and simple. We're just taking our rules and going the other direction. If you were struggling with the last one, you may need to pop in and join my Zoom tomorrow at 10:30 or today at 10:30 if you're doing this earlier in the morning. And that way you'll be able to pop in and ask me any questions you have. Because we only have one more video, and then it's time for the final. We're almost there, guys.